Wow.
Good morning, Peter. Hey,
Hey, good morning, David. We're live. It's scary. First time
yeah, this
live.
is a little bit terrifying. We've been doing this podcast for a little while now, and usually we record them a day or two ahead and post them. And so we have the benefit of some skilled editors who can make us look smarter than we really are sometimes. But now we're live. No
Yes.
training wheels.
No, no training wheels. Just go do it. I mean, hey, if anybody's out there watching us or listening to us, which we hope there are plenty of you, welcome to the first one. I hope you enjoy it. And, we apologize for, I am sure, the many mistakes that we will make today. But hey, got to start somewhere.
Yep. And as
Okay.
Peter said, we've been doing this for a few weeks, talking about, a few months actually, talking about data and artificial intelligence and what's happening in the market and sharing some of our hard won nuggets of wisdom. But we haven't had a name all that time for this podcast. We've just called it
I know.
the podcast. We officially have a name now.
I call me data. Look, it's one of the many that we tossed about, and we never settled on anything. And I guess this is the one that we're finally settling on. So at least it's real. We can at least call us something finally, not the Peter and David show.
Yes, call me data. The only problem with it is it requires me to say data instead of data, and I have 30 years of saying data, so I'm gonna have to train myself to say call me data because call me data is probably some Star Trek
I
podcast
was just going
somewhere.
to say that it sounds very Star Trekky, and
Yes.
hey, we're old, so we can say stuff like that.
Yep, we
That's what,
can.
and of course, I have to comment on one thing, David. I mean, in spite of the fact that it's snowing out where I am, you're wearing a Hawaiian shirt, which I'm jealous. Had you
Absolutely.
told me you were doing this before this, I might have actually joined you.
Next time. There's always next time. So it's my attempt to it's my attempt to ignore the fact that it's snowing in New York and just
I
make it
know.
feel like it's summer. So
I
um
wish it was.
yeah, as you said, we're doing this live for the first time. I was a little bit worried about hair and makeup, and then I realized I don't have any hair. So that was one thing I didn't have to worry about. But we have a lot to talk about. So
So we have a lot. We have a lot to cover. We always do.
all right, so here, just as a
Yeah.
bit of foreshadowing, here are some things we're going to cover today. We're really going to talk about three things. First, we want to share some of the thoughts we have around what are the common barriers to implementation for really companies really being able to implement modern AI solutions, especially generative AI, because we've been working with companies for quite a while and have seen some of the patterns of what makes it hard. And so we'll talk a little bit about what can help you be successful. Then
Yeah.
we're going to talk about reasoning models, LRMs. Language reasoning models are sometimes called large reasoning models, which are, I would say, sort of a subcategory of generative AI and large language models. And we'll
Mhm.
talk about what those are and where you might use them. And then we're going to talk about something that Peter's been doing some experimentation with, which is the new deep research capabilities announced by OpenAI recently.
Yep.
So
Yep.
those should be
So
three good meaty topics. Let's jump in.
yeah, no, let's jump in. Let's start with some of the things, David, you and I have learned in the last all the customer meetings that we've had, all the conversations we've had, and obviously with our experience, you take away a lot from these meetings. And I think one of the goals of this podcast that David and I had was not to always focus on what's out there and talk about technology constantly, because I think there's a number of other podcasts out there that do a great job of that, and I don't want to kind of rehash everything. But I think where we had the little our spin on it is that deep business experience in doing the implementation work and understanding how you really apply this technology to complex business problems. So I'd like to, kind of focus on, I think, on that a lot more, because it really, I think there's a lot of people out there need to understand, or this would help them understand how to actually apply this tech.
Yeah,
But
hopefully that's useful to people. I think it's been really interesting for us to learn as we've been working in this field for a long time.
mm,
So let's tee up this conversation about barriers to implementation. And I think the way I think about this is one of the beautiful things about the new crop of AI tools, generative AI tools
yeah,
especially, is that they are very easy to get started with. And in fact,
right.
if we're talking about Gen AI, as long as you can type and have access to a web browser, you can kind of get started playing with them. And the tools are
Mhm.
being increasingly integrated and built into the tools that you use every day. So if you are a Microsoft user, you might have access to
Right.
Microsoft Copilot. If you're a Google Workspace user, you may have access to Gemini. Or
Right.
you could have downloaded the applications or running on web, whether it's OpenAI's models or using Perplexity or using Claude from Anthropic. So getting started isn't the problem. But I think the problem or the challenge comes when you want to do more than just use it as an ad hoc tool for personal productivity. How do you
Right.
actually create a system? So, Peter, like, you want to
Right.
start this? Like, what are some of the challenges that people have when they want to make a real application or real system out of this technology?
Well, I think, when you sit down as a business user and you look at the problem, very often you approach it, well, there's generative AI, there's large language models that will solve my issue. What they don't realize, that when they're not thinking about it, is that if you have a complex business problem that requires many, many steps and, pulling in information from a whole bunch of different sources of information, maybe you're cruising the web, maybe you have API calls you're making, whatever it is that you're doing, as a human, you're thinking through a problem. You're coming up with a series of steps that you follow to get to a conclusion or get to an answer. And most business problems require reasoning. It's not just the generation of text or images or whatever. Now, generative AI is fantastic at generating text, generating content based on a prompt. And a lot of the tools out there do a phenomenal job at doing that, whether it's generating code or generating content, based on your prompts or your prompt engineering. But they don't reason. They don't think through problems. They're not doing that for you. You see a lot of companies approach it again because the technology I think is moving, and we've been at this from the very beginning, and our conversations have changed dramatically from our first conversations to the conversations we're having now, and
Yeah.
we're seeing business users get certainly more sophisticated about what they want to do, but how to do it is still, I think, there's a level of complexity there. Um, I am definitely seeing the kinds of problems, and I'm jumping around over here, get more difficult for traditional regular language models and really require, I think, a much more sophisticated approach to solving these problems.
Okay,
Um,
so we'll park that as the foreshadowing for our conversation next
right,
about large reasoning models or language reasoning models. But what you were saying about sort of breaking down the problem into steps is really interesting because I think, like any technology, you as the user have to understand, at least at a basic level, how you would solve the problem. You can automate some of the work in solving it. So a large language model is fantastic for automating the process of reading through and picking out key points from lots of documents, for example.
right,
But if you don't know at a fundamental level how you'll solve the problem, you're not necessarily going to get the kind of results you want from a model. And
correct.
let's talk then. Maybe the
Let's
beginning of this is let's talk about this concept of prompt engineering because which is sort of an absurd term because it really just means asking a more precise question or issuing a more precise instruction to a model. But I think to some degree creating the right instruction that specifies what you want done and how you want it done and what kind of results you want back is maybe the first step that you have to take in getting the results you want.
right. So I think you're correct, and I think unfortunately we're gonna. I don't want to jump ahead too far here because the whole next topic we're going to speak about will go into what we're talking about now. I think in a lot more detail. But I think you're right. Prompt engineering only gets you so far. And language models themselves only get you so far. And it's understanding how they work underneath the covers that will, it'll help clarify this, I think, a little bit further. But it's only going to get you to a certain point. And, the models that are out there, like you and I know, they're great at generating content. They give you this false sense that they're actually thinking through a problem, but they're really not thinking through a problem. Statistically, they're just looking for the next viable token to attach to another token to create text. Um, and a prompt to a model will help guide that by, sort of, maybe looking at this way, putting its finger on the scale for certain weights to generate certain tokens. And that's what prompt engineering really effectively does. It kind of primes the model to think a certain way or to generate tokens a certain way.
Yeah.
There's only so far you can get with that.
Yeah, but not to say that you can't create real business applications with large language models.
Right.
We've done it, right? But I think that the takeaway here is it's not just a large language model out of the box that's going to get you that application. You've got to do
Right.
something else, right? And for most use cases, that something else has to be more than just prompt engineering, I think.
100%. And so some of the cases, some of the business problems that you and I have worked on, where they are very domain specific, without getting into details, they're very, very domain specific. And a regular model isn't going to solve the problem very well. You don't, again, we don't know what these models are actually trained on, but internally, you might have a fairly large or a significant amount of, again, very domain specific information that you would like to use. Now, we know in order to leverage that, you need to incorporate it into the model so that you get better results from your prompts. A couple of ways of doing that. There's RAG out there, which is in many ways fairly simplistic. There are other tools like fine tuning or pre tuning, or even building a model entirely from scratch that might work for you with your custom information, with your proprietary domain knowledge. And you and I, and these are barriers to entry. These are challenges, I think, in most organizations, because I think most organizations don't do a very good job at organizing, if they even realize they have data to organize, which I
Right.
think is very often the problem. Like, we walk in and we might have a conversation with a customer and we'll start asking questions about their systems and not realizing that that's really valuable information to put into a model.
Right.
That's
Well,
that's
let's step through some of the approaches you talked about, but I think what we're really capturing here is the idea that regardless of which technique you use, fine tuning or RAG or other things, it's essential to bring your own data to that model, right? That
right,
idea of domain expertise is predicated upon a model using data that is reflective of the business and the industry that you're working in. And
right.
it's really funny because I think this idea of having to explicitly say that to get any result that someone else couldn't easily replicate means you have to introduce your own data to a model. That is fundamental to working with generative AI. But it's also funny
Mhm.
because we never used to have to say that. When we were working with, we'll say, traditional AI,
Right,
you started with models that were effectively empty algorithms or very crudely trained models. And the first thing
right,
you did was maybe through supervised pre training or supervised learning, you were introducing your data and you were training the model repeatedly until you got the kind
right,
of performance you were looking for. And I
right.
think that that step of introducing your own data, your proprietary data, or your secret sauce or your domain knowledge, it's not as obvious anymore that that needs to be done because you can
No,
use a large language model without introducing your data. It's just that you're going to get the same results everyone else using that model is going to get.
100%. And I think that's most don't realize that's what's happening. And I think
Right.
that's unfortunate. Now, you can try to introduce your own data, through a prompt, but that also becomes highly limiting, very cost ineffective. I mean, it could be very expensive very quickly if you know what you're doing. Um, you really need to take your information, like David, like you said, and you and I come from a world where you trained models, not AI models, but traditional statistical models
Mhm.
using your internal data. It's the first thing you did. It's like I trained the model, supervised or unsupervised, whatever tools you used, and that seems to everybody's moved away from that. Now it's like, well, I
Right.
can go to a large language model where I don't know what's in that model. I have no idea what's been trained on. I don't know what the corpus is. It's statistical in nature, but it's not going to necessarily give me the right answer or an answer I want, or like you said, give everybody else the same answer that I got.
Right. Well, and many of the people who are watching this may have actually, whether they think of it this way or not, they may have introduced their own data into a large language model conversation simply by doing something like uploading a document or pasting in some
Right.
content into their query or their prompt. And that works to a degree, right?
Mhm.
You're saying, please tell me what's in this
Right.
document, and you're kind of introducing some of your own content. The problem is that that's still very ad hoc, right? You
Right.
can't build a system out of doing that. So let's
No,
let's
you
talk
can't.
about some of the like how do you do it? What are some of the ways we've done it?
One of some of the ways that we've done it when we've sat with customers, I mean, look, we always go through a process. I mean, let's test on simple cases where, the problem that they're trying to solve. and then we kind of work our way up the chain. Invariably, again, it depends on the complexity. We tend to trend towards, at least this is what we're seeing a lot of, is you have to take some of these models and use your internal data. So we'll start investigating what data is available, internally, and is it viable data? Is it good data? We might do a POC around some of that information and see if it's really good data. Some cases, the data you have internally is not good and not relevant, and nor will it help the problem. Sometimes it's excellent data. Maybe it's not managed. We'll look at that. We'll evaluate it. We'll get a sense of the information, and we'll make recommendations about fine tuning a model because we think very often that's how you're going to get the most out of it. We'll
Right.
decide, right? Like I said, what model is best for you of the numerous that are out there. And now going forward, as the problems get more complicated and the questions become much more complicated, certainly the business processes that we're seeing that people want to solve with AI are becoming much more complicated.
Right.
We're trending into a whole different direction now. Um, I'm sorry, good.
Yeah. No, I was just going to say, as you're talking about, the quality and the accessibility of people's data, the one thing that generative AI has really done that is a huge positive is it has broadened the scope of data that you can get access to and use at a fairly economical way, right? So I'm talking
Right.
about all of that data that's sitting, unstructured data sitting in emails and documents and
Mhm.
chat logs and web logs of conversations with customers, et cetera, et
Right.
cetera. That's always been around, but it previously took a lot more effort to access it and use it. And
Right.
large language models are pretty good at picking out the nuggets of information from all of that text.
Right. No, precisely. And you mentioned this, and I think you and I have been around for a long time, and a lot of this stuff has been spoken about by organizations for a long time. How do I use all this information that I have sitting? I have, petabytes of unstructured data sitting on disk someplace, all over the place. But, and it's like you want to use it because it's in many ways it's the knowledge of an organization. And yet it's very difficult, given current or given past technology, search algorithms, it just wasn't very good. You had
Right.
to weed through hundreds of documents to get, maybe what you were looking for. And that's just not effective,
So you
you know.
mentioned two of the several ways that you can sort of, I'll say, industrialize bringing your data into a model or into the purview of a model and use it as part of a solution. You mentioned RAG, retrieval augmented generation, and you also mentioned model fine tuning. Shall we
Right.
talk for a couple of minutes about each of those and what they are and where you might use them?
Um, sure. I mean, you and I have, we've spoken about this again to clients many times, and I tend to, you're right. There are cases where one is, I think, more relevant than others. Um, there is the easy case or the easier case. Maybe, for instance, and I'll look at it from a finance perspective, because that's an easier one. It's the one that you and I know well. You're looking at 10Ks and AQs. That's an easy one. So
Yep.
you can grab all these PDFs that are sitting on the SEC website, and you want basically a tool that would allow you to look through it very efficiently, and ask questions of it and extract that information and display it to you. And this is, I think, where RAG is very good. It's easy. You take all the information, you tokenize it, you create embeddings. And for those that don't know what embeddings are, it's basically taking this text and creating a numeric value from it, a very long floating point set of numbers, and without getting too much, identifies it in, in space, for instance, in a vector space. And with that, you can find uh, topics that are very similar to each other using other methodologies. So it's a really efficient way of finding things that are similar and looking and querying this massive corpus of information.
Right.
It's relatively inexpensive.
So if I wanted to, let's keep your example, if I wanted to look through a bunch of 10Ks and 10Qs and ask questions about them using a large language model, I would first tokenize or embed all of those documents through the
Right,
RAG process. I would convert them into vectors and tokens and sort of, I'll say, codify the content and the information. And then at the
right,
time that I'm asking the question, we'll use that to search and extract chunks of those documents, not necessarily the
right,
entire documents, but chunks
right,
of the documents based on similarity to my question. And we'll
right,
take my question plus those chunks of documents we searched and hand off all of that to the large language model and effectively
right,
say, here's my question, and use these chunks of text to answer the question. And
Correct.
so it sort of gives us sort of it feels like you're searching and answering questions over your own data.
Right.
Um, but it's a little bit of a brute force method to do it, of course.
It is. You're basically taking external content and you're putting it into the context window of a language model. And depending on how much information you pull back, you might exceed the context window and lose some of what you pulled back.
Right.
But you're right. It's not reasoning per se. It's really a way of enhancing a prompt into a model. You're
Yep.
providing your own data, though. That's really what
But
you're doing at the end of the day.
But as you said, it can be very, very effective. It can be very cost effective because it's
Right.
relatively simple to set up. Now, it's not something that the average non-technical user is going to instantiate on their own, but it
Right.
is relatively easy compared to things like model fine tuning to get that up and running. I
Right.
think it often for a lot of organizations, it's a good first step. And for a lot of use cases, maybe it's the only step, right? But
Oh, absolutely.
yeah, but there are going
You
to be
know,
others where you have to go beyond it because, as you said, also, that process of loading data ahead of time means it's not responding to new information in real time. You have to periodically refresh those documents that you've tokenized,
right.
and if a lot of people are using it, you're processing a lot of tokens, and you can drive up
Mhm.
your inferencing costs. You can run out of
Right.
space in your context window. There are some drawbacks for certain types of use
Right.
cases, but it's
Right.
a pretty nifty way of doing it.
It's a nifty, simple way of doing it. You're going to take all this
Yeah.
information you pulled from other sources, you're going to summarize it using an LLM, and it's going to give you a response back.
Yep.
I think and you have to realize this is it's not thinking, it's not reasoning. It's really just, in many ways, it's still a brute force approach. You're putting all this information into what's called a vector database, which is a database, as the name sounds, of vectors, numeric vectors, thousand long numeric strings, or I'm sorry, thousand long floating point numbers that identify a piece of text. And then you're using some fancy math, cosine, similarity algorithms to identify other vectors that are similar in from a numerical standpoint, and
Right.
using that to retrieve the text. Purely brute force. Not thinking. It's not reasoning. It's not doing any of that. It just says this piece of text is very similar to this piece of text. It's similar to this piece of text, which is similar to your question. To put it into the context window of a language model, and please summarize.
So the fact that you're looking at text similarity means that it casts a pretty wide net over what it might
Mm,
retrieve and present to that large language model. Absolutely.
100%. 100%.
Now,
So you're not necessarily getting back what you want.
right. There are some, of course, there are some ways to mitigate that a little bit.
Mm,
You can build an
right.
application that pre-selects which documents are available to do that similarity search on based on some
Right.
criteria that you put in place. Or my personal favorite, just because I am a fan of graphs in general, is GraphRag,
Right.
um, where you, as part of that pre-ingestion process, you build a graph database that links together documents with some semantic linkage and content. So in a 10Q, it
Right.
might have the name of the organization filing the 10Q, and it might have all of the other organizations, companies, and individuals, for example, the entities that are
Right.
mentioned, and explicitly store that they're related to one another. And what's
Right.
interesting about that is you can then have a RAG system that instead of doing pure text similarity, actually factors in these relationships that you've instantiated ahead of time through building out this graph, um,
Right. Right.
which is, we'll say, more discriminating about the results that it returns.
100%. But you and I have discussed this many times because you fall on the side of graph databases, and I fall kind of on the other side of graph databases. There is, and I think they are certainly applicable to a whole class of problems. But
Yeah,
like you said, and you said it yourself, is building that graph representation and those relationships in a graph database. That takes effort too. That takes work before all this occurs
yeah,
to identify those relationships so that when you query it, you get back good
yeah.
results.
Absolutely,
Um,
it's not non-trivial. And look, I do have to
right.
confess to being a reformed DB2 DBA. I cut my teeth on, well, when I cut my teeth, relational databases were like the newest thing in database technology. And I spent a long time, my
Hey,
brain thought about tuples and relations. But I've now seen the light of graph databases.
I've got you beat on that one. I learned SQL on a VAX, old PDP, when
You
SQL was
definitely
first
had me.
coming out. Yes,
Yep.
and it
Yep.
was not pretty. So yeah, then like you, I did some DB2 work, and yes, we are certainly dating ourselves big time.
Yes.
Um, but then I morphed into the more classic traditional relational databases like Sybase and Oracle, and my favorite Postgres, which I absolutely love.
Uh, Postgres, I'm a big fan.
Yes.
And I'm also a fan because you can build graphs in a Postgres environment. So
And you can build vectors in a Postgres environment too with the
yes,
plugins. That's why I love
yes,
it. It's
it's
kind
kind
of
of the
it's
Swiss Army knife of
I was just
databases.
going to say that absolutely, and it's
Yeah.
I got to tell you, the funny thing is, we'll segue to a funny story. Years ago, I was trying to optimize, which was a distributed what do you call it? A distributed SQL database, and it was a column-oriented database. So by definition, you could tend to distribute them to multiple servers, and they would
Right.
shard the records and all that stuff. And it was a seven-node cluster, and it was used for a trading application. And trading application, which to me, you don't use a column-oriented database for trading applications. It just
Nope.
doesn't make practical sense, especially a one that is split across five nodes. You're they're not good for certain types of applications, and high volume, high
Right.
transaction applications is certainly one of them.
Right.
And they were having all sorts of performance issues. They're running this massive cluster. I just had to see if I can do what they were doing on my laptop, running Postgres. And a lot of things in finance use something called bitemporal query logic. Basically, you're trying to pull data back between two timestamps. Sounds trivial.
Right.
Turns out it's actually computationally intensive in a relational database, primarily because in most cases it's not indexed, because most databases, at least maybe now they do, but then they didn't index them. I was happy that I was able to get this massive database running on my laptop orders of magnitude faster than this production cluster. That's how much I like Postgres.
All right. Well, this is not a paid commercial for Postgres, but
I know,
if
but
you're ever in
and
doubt, Postgres is the
segue.
answer. Yeah.
But back to what we're talking about, and why this is all hard to do for organizations. And I think some of the things that you talk about, because you and I can go off on 47 different tangents
Yeah.
over here, start telling stories about all the time that we've had working on these systems.
Yeah, and hard to do is all relative, right? This is there are emerging lots and lots of frameworks and good patterns for how you build this, right? So there are lots of
Right,
frameworks and patterns for retrieval augmented generation or for graph rag and even for fine tuning, which we'll talk about next. But I guess the point is where where basic ad hoc usage of a large language model is entirely within reach of anyone with a web browser and a keyboard, building solutions that scale and behave predictably does take a little bit more architecture as well as technical skills. And this is where I think a lot of organizations sort of hit a barrier because it starts out so easy and then it gets hard very quickly and they're caught
right.
off guard. Yeah,
I think you can get through a simple proof of concept in many cases. Some organizations were not needing to be super sophisticated, but I think when you try to then take it to a production level, you rapidly need a different set of skills, which
right.
is not indicative or not in most organizations. And I think that's where having some expertise to kind of walk you through how do I best use my data? How do I really solve this problem? And you
Yeah.
and I have seen it before. We've seen customers say, "Well, I got this result with this. Why can't I just scale this out?" And then we
Yep.
sit there and go, "Okay, we have to now educate and walk you through it and explain why this is actually a little bit more difficult. In many cases, a lot more difficult than you're thinking it's going to be."
So
You know,
let's skip a couple of architecture patterns and jump to fine tuning, which sort of represents something at the closer to the other end of the spectrum of sophistication.
right,
And I think everything we've talked about to date, whether you're talking about prompt engineering or various forms of RAG, none of them are fundamentally changing what is in that large language model. They're just
no,
temporarily presenting additional information or context to that model that it uses when you're asking questions. But when you're done with your session, the model looks the same as it did yesterday and the day before that and the day before that. That's
right.
not the case with fine tuning. Like in fine tuning, now we're talking about something where we actually change the model, or specifically the weights in the model.
Right.
Um, yeah, let's talk
Right.
about that a little bit.
I think this is the next level of sophistication, and this is where things require a different set of skills. As David said, you don't change the model when you're just querying the model with RAG or prompt engineering. You're not changing the model. You're not changing the parameters and the weights that have been encoded in the model through a training process. What firms like OpenAI do is they gather up all this information, this corpus of information, they break it into tokens, they clean it, they strip out certain information, and they create a model. And that model consists of parameters and weights and other features and other layers in the model. With fine tuning, you're now taking your data and you're really incorporating it into the model. So now to compare it to prompt engineering, normally with a prompt, if I want to include some information, I have to include it in every single prompt, maybe the same piece of information over and over and over again. Um, with fine tuning, I tune the model. I change the parameters and the weights of the model itself. I take my information, my relevant information, my domain specific information, and I tune it further with my data. So now when I query the model, my information is already there. I don't have to include it in a prompt anymore. So it's a level of sophistication of fine tuning. Normally, you only tune a small percentage of the parameters, maybe 4 or 5%, some cases more, some cases less, depending. But bottom line is, I'm incorporating my proprietary information into a model so that subsequent uses of the model, that data is already there.
Yeah.
I'll give you maybe for instance, like even in medicine, for instance, maybe we're talking about ICD codes for argument's sake. Now, something like that might not be in the model. Most likely, it's not in the model. Or if it is, it's not to the level of detail necessary. Maybe I want to tune a model to be able to generate ICD codes for specific medical conditions.
Right.
I would need to take all that information, incorporate it, or train the model so that it has it. So next time I ask it, well, with this medical condition, what is the code that should get generated? It knows what I'm talking about, so to speak. It understands the language of ICD-9 codes and diagnoses and everything else, where other model might not understand that.
And let's be really clear. Like if you were to start with OpenAI 3.0 and fine
Right.
tune it, which as an aside, we know you can't do because it's not an open weight model. But if you
Right.
were able to get access to the weights, you were to start with OpenAI 3.0 and fine tune it, when you're done, that model is not OpenAI 3.0 anymore. It's a completely unique, different model. So I think that's an important thing when we talk about changing the model. You're actually fundamentally altering the DNA, if there is such a thing, in the model. And
Right.
what you're left with is not the same model you started with. And in some cases, it might be completely unique in all the world. No one else is going to have that model.
Right, and that's the beauty of it, fine tuning the model. You're making it specific for your domain. You're tuning it for your domain. By definition, nobody's going to have the same parameters and weights anymore that you have.
Right.
The way it's going to change. There'll be a new file or files that are generated that sit on top of the model. But
Right.
it's different. It's for you. Again, this is, you and I have gone back and forth on this. We've been speaking about this for a very long time. At some point, most organizations are going to need a small language model or a domain specific model that is relevant to whatever it is that they do well, because it will become an edge for them. It's using their data in a more effective way.
Yeah.
And I think that's, something certainly and we said earlier at the beginning of the conversation, most of the conversations we're having now are leaning in that direction. It's how do we
Yes.
fine tune a model? Now, I still think, and I've seen definitely, I would say, pushback against that, but maybe they don't need to do that. And I think that's where people are still getting educated on what they can do and need to learn more about, this technology.
Yeah, I think that's right. And we should also point out that most commercial solutions that we can build are going to incorporate multiple different approaches. It's not a one size fits all. So you may have
Right.
multiple models, and some of them may work in RAG, and some of them may be fine tuned, etc. And it's really interesting because that means that, as you said, the rise of task specific models is
Right.
really important, but there's different ways to get to a specialized model depending on what you're trying to do.
Right. Absolutely. There are definitely different ways of getting to specialized models. Bottom line is at the end of the day, you still need your own data to get there.
Right.
Your custom data. So, and goes back to what you said at the beginning, David. It's, when we used to train the models, it was always on our proprietary data. You need to have control of your proprietary data um, to really
Yeah.
get the most value out of it.
So let's talk about a couple
So,
of other things that you need. I mean, you need significant user input or user feedback. We'll
mhm.
talk about that process of testing and refining
Right.
and fine tuning. And you need guardrails. Um,
Yes. Yes. You need some controls. Absolutely.
yeah,
Um,
I think maybe start with the guardrails, right? It's irresponsible to take any model, whether you fine tuned it or it's off the shelf, and put it into an application without building some additional guardrails around how you want it to behave. Would you agree with that? Am I overstating it?
no, I don't think you're overstating at all. I think you're absolutely correct. And there have to be some controls in place. And you know this even better than I do. You're far more knowledgeable and responsible AI and putting guardrails around some of these systems. But yeah, you do. You need to have some level of control for what it spits out. You don't want it to do. You don't want it to say things
Right.
that would embarrass the company. You don't want it to generate information that is sensitive in nature, or putting out PII, identifiable information. So yes, you have to
Yep.
put controls in place at every step of the process.
Yep. I think that's
So
really important. And one of the things I always remind people is whether it's a closed model or whether it is an open weight model, none of
mhm.
these are open to the extent that we actually understand what information was used to train them, or very few of them. There are some
Right.
fully open models that disclose all the data used for training, but for most models, you've got no idea what information was used for training.
Well, so I think you're bringing up a very valuable point here. I think it's one that's not been spoken about extensively. Open is kind of a misnomer, coming up from, decades of using open source software where it's open code, everything is open, you see everything. It's there for everybody to look at. That's not true with models. They say open models, but really they're opening up the weights. In my case, they're not opening up the code that generated, and they certainly, and at least I've not seen any of them yet, open up the corpus that they're putting into those models.
Right.
So you truly have no idea what's in them in terms of what information's been piped into these models whatsoever.
Right. There are a few, primarily like academic research models that are open in terms of what data was used for training and what that corpus of documents was, but vast majority you have no visibility into that. And where that matters is I think that if you then assume that that training data is full of good information and bad information, it's full of biased and unbiased, it's full of
Right.
all sorts of bad content as well as good content. The models during training cannot and do not, they are not designed to differentiate between what's true and what's false, what's harmful and what's helpful. That is not part of the
No.
mathematical underpinnings of a model. That's only achieved through the fine tuning and the human feedback that happens before a model's released, or through the guardrails that you choose to put around a model when you deploy it.
Right. 100%. Like you really, truly have no idea what's in those models. So, and this is a conversation you and I, again, have had multiple times. You don't really know what's in them. And many of them just cruise the web or scan the web and pulling content from the web. Now, some like Claude and Anthropic make an attempt at cleaning a lot of this information of, called harmful content. But everybody's definition of harmful content is different, so it's their definition.
Yep.
But you really don't know it's there. So, like you said, you got to put controls, guardrails on the input side when you fine tune it to make sure the data you put in there is good data, because a lot of that is done during the data loading process or the fine tuning process or data cleansing process. Don't even let it get into the fine tuning process.
Right.
And then after that, having other models uh, look at the output that's generated before you actually see that information.
And let's be clear. Are you suggesting that because you don't understand or can't understand what was used to train a model, that you shouldn't try to build any commercial solutions on these models?
No, not at all. I think you have to then make it work for your domain, and that really
Exactly.
involves fine tuning. I mean, look, at the end of the day, if you want full and absolute control of a model, you build them from scratch. Now, most don't do that because it's
Right.
cost prohibitive, but it is the only way to really, truly, truly build a model where you know exactly what's going to be in that
Right.
model.
But to be clear, we do believe that there are ways to mitigate the risks of this. It's just that those aren't
Right,
usually implemented strongly out of the box, and you have to do some extra work to
right,
make the model behave the way you want it to behave. Um,
right,
One of the other interesting questions we get a lot of time is someone will say, "Well, what model should I use?" And that's an impossible question to answer up front for a couple of reasons. One is
right,
um, we can talk about the futility of benchmarks and the fact that you just can't take a problem statement and magically pick which model's going to perform the best against it. And then two, as you were talking about task specific models, it also reinforces the point that most organizations, because they have a variety of different things they want to do, will require multiple different models to be used in different
right,
capacities. And so that
right.
question of, hey, should I use, OpenAI or Anthropic? Should I use Gemini or should I use Llama? That's actually not an answerable question the way it's asked, is it?
No, not at all. And it gets even more complicated when you start talking about some of the open source models and all these other models that are out there. And you have to take into account the economics of running the model, what you're trying to accomplish with the model. Like there is so many factors and so many questions that we ask. When asked that question, we in turn ask a thousand other questions because it's not a black and white response. It's not just, oh, do this or do that. It really comes down to what are you trying to do? What's the cost do you want? How much do you want to spend? And all sorts of other variables that have to be looked at.
Right. And it requires some trial and error still. I mean,
Yeah,
I wish I could
100%.
say that we had gotten to the point where we could just look at a problem statement and say, this is the model that will work, but sometimes there's some testing required.
Oh, 100%. I think there's always, and we've done this to customers where we're doing extensive amounts of testing. And, we've looked across different models and the answers you get on one versus another are very different.
Yeah. Well, I feel
You
like
know,
we've gone pretty deep on what are some of the challenges that you have to cross or overcome on the road from ad hoc anecdotal use of large language models to actually being able to build capabilities and systems around them and
right.
digitize the company. Um, But you, to be fair, foreshadowed that sometimes I'll call it a vanilla large language model is not the right answer for some problems. And
Right.
you mentioned reasoning. So, so we move on to talking
Yes.
about reasoning models.
Now let's talk about reasoning models. I think
Okay.
this is important because the class of problems. So let's walk back a few months when we were trying to solve certain classes of problems and we were using purely large language models. And we got good results. Not great, good results. And a lot of these problems that we were trying to solve were what we would call chain of thought reasoning problems. You're sitting to try to solve a complex problem. Maybe I'm trying to explain to somebody how to fix an appliance, or I'm trying to walk them through a math algorithm, or whatever it may be. But it's a series of complex steps that as humans we do intuitively and easy. But getting a machine to do that, whole different animal. And then we're seeing, customers come to us now and say, hey, I have this problem that I would like to solve. And initially we would have said, great, let's fine tune a model. Let's do that. That will get you pretty far along where you need to be. And that coupled with prompt engineering will get us, close and additional, validation and user feedback. And how do we test feedback at a large scale? And all these types of questions would come up. But there's a new class of models, and calling them a class is really not the right answer. It's an add-on to language models. It's additional, uh, more sophisticated language models that have now incorporated, we'll call it reasoning. Um, and they're able to solve much more complicated chain of thought type of problems. Like, how do I fix this? Well, that's complicated. Let me, you know, ask you a bunch of questions. Let's go back and forth, much like humans do, and
Right.
I'll generate an output that walks you through a set of steps.
So let's do a couple of
So,
things. Let's be clear about these models. So I think we call them sometimes language reasoning models or large reasoning models. They're often called
yep,
LRMs. That's not as you said, that's not a label that's applied in the marketing material. You're not going to go out there and be given
no,
a choice between an LLM and an LRM. It's just a characteristic of the way a subclass of large language models have been deployed and trained. So some
right,
large language models are reasoning models and some are not. And you're
correct,
not going to find an easy way, a label on them that says, hey, this one's a reasoning model. But clearly some of them work that way. And
Right.
let's talk about a bit about chain of thought because we haven't really talked much about that concept today. Um, can you give us a short definition of chain of thought reasoning?
It's a step-by-step reasoning process. It's like I do this in step one, I do this in step two, I do this in step three. I'm reasoning through problems. It's much like doing a geometry proof when you were in high school. You're walking through a set of steps. You're reasoning through until you get to the end state. That's
Right.
effectively chain of thought. You're telling the model itself how you would solve the problem. Okay, so what the reasoning models do, rather than you do that with a language model, it does that for you. And then it validates its reasoning steps and it makes sure that it's reasoning about the problem correctly and it tests itself and it might alter its reasoning steps based on what it's asking itself. So it's if I have a complex problem, might have a very complex set of steps to solve that problem. So it's again chain of
Right.
thought. You're walking through solving a problem, much like, and I always go back to math, but you're using it for like old geometry class and you're solving proofs.
Yeah. I find it really fascinating because it sort of feels counterintuitive sometimes that chain of thought would actually work in a computer, in something that's fully automated and digital. But if you
Right,
understand how these models work, you can actually begin to get how asking them to do more straightforward predictions in sequence is going to give you a different answer than just asking them to go from the question to the final answer. It's
right.
not exactly the way it worked when I was in grade school and I was doing, having to show my work on my math test, but it's not that different.
Right. It's not, and the one thing to keep in mind too in chain of thought, remember when you're solving a problem, it's not like you're forgetting the last step. You're storing it in your memory. Now, memory memories paper, whatever it is, but you're storing it someplace. And these LLMs, and I'll call them LLMs, even though I know it's not generally accepted, they have the concept of memory or is reasoning working memory where the results are stored there. To go to
Right.
the next step and process it further. And this is something that is, it's this kind of scratch pad type of memory that's utilized as part of this reasoning process.
Yeah. So as you said, they know what the end goal is and they pursue it one step at a time. So
Right.
generally these models work along a couple of principles. First, they come up with a plan, right? They say, here's what I think I need to do,
Right. Right.
and they outline what they think is the sequence of steps they'll go through or the sub problems they might want to solve. That's pretty neat, pretty comparable to the way we as humans often work.
Right.
And then they solve those steps, and you mentioned that they evaluate step by step whether they think it's a valid answer. What's
Right.
particularly interesting about some of them is they may, instead of saying, I'm going to solve the step one time, they may try multiple different ways of solving the same step and then
Right.
evaluate to say, okay, I got 100 answers or even 1,000 answers. Which
Right.
one is the best answer?
Right. It does that. They have these self-consistency and validation loops that they'll go through and make sure that their thinking is rational, so to speak. And it might find that the path that it went down was wrong and it'll try a different path. So it might try hundreds of paths before
Right.
it comes to an answer for you. Um,
Interesting aside, it's so that's turbocharged trial and error in a sense, right? Trying different approaches and picking the one that works. Um, I
it's many ways.
You've
Go ahead.
probably
Sorry.
seen the stories that have been around for a long time that there've been scientists who've said that the brain structure of octopi, octopus plural, of octopi is so sophisticated and they show so much ability to learn that they actually think that the largest factor in octopi not being as smart as humans is physiological. It's their short lifespan, that they literally don't live long enough to
Interesting.
develop writing and the types of communication and
Oh,
preservation
interesting.
of knowledge that allows humans to not start from scratch every time a new human is born. Um,
I did not know that's fascinating. I had no idea.
Pretty now, I'm not sure whether that's proven, but I've certainly read that and heard that many times. So it's there's a similar thing with humans, which is a human could, in theory, do trial and error and
Mhm.
learn almost anything through enough trial and error. We have the capacity in our brains to do that. The human brain is far smarter than any large language model ever developed.
Right.
We don't have perfect memory, but we have a lot of
Mhm.
computing power in our shiny
Right.
noggins.
Right.
However, our problem is also physiological. We don't have the energy, we don't have the electrical power to
No,
do trial and error at, to do it 24 hours a day, and we can't do it thousands and thousands of times over. Maybe a handful of humans can perform at that
no,
level, but most of us can't. So it's actually interesting because I think large language models are taking an approach that is not impossible or not that different sometimes from what a human might do, but they exceed our organic capacity to do trial and error and to remember the results of 1,000 possible answers and
right,
compare them and pick the one and then still
right.
remember what the next step in the process was, et cetera, et cetera.
Right. No, you're absolutely spot on. And I think that's super interesting. And they're finding that a lot of these models used in scientific discovery are making scientific discoveries,
Yeah,
which, everybody was concerned about, these models, but they are incredibly valuable now in going through scientific discovery because precisely as you said, they can test thousands of different things
yeah,
instantaneously and come up with results where, our little brain is uses really 20 watts of power or 24 watts of power. Clearly we have developed over the millennia shortcuts to thinking and coming to conclusions. Whereas this will test everything. And I think, these reasoning models are really great at this. This is what they're good at. So they want to be, and I want to be clear, they are architecturally different than traditional models. There are other components to them. They might have, neural symbolic integration. So they might integrate with math processing tools that are external from the model itself. It might recognize some math here, some addition, and goes, well, language models don't do addition particularly well. I need to go to
right.
something else and do it. Or it might have these tools to scour the web and incorporate that information. They have specialized fine tuning involved in them. Some of them are really, very specialized fine tuning, but architecturally they are different. They might have more, transformers or attention heads, or there's definitely things that are different about them than traditional language models
Yes.
because we're trying to get them to reason, to think through a problem.
But at the fundamental level, they still use the attention heads and transformer architecture of large language
Yes,
models. So I think what's important is some of the limitations of LLMs are still present in the way that LRMs
100%.
think. Yep.
100%. I think this is a good segue to things like deep research from OpenAI, because I think we're running up a little bit against
Yeah.
time.
So
Um,
last comment on LRMs before we go. Most people again probably have not used the term LRM or reasoning models, but yet I think most of the world has been talking about a large reasoning model for the last 10 days.
right. Yeah. Well, DeepSeek
Right.
is a reasoning model. And
Yep.
if you load DeepSeek on your computer, which you can certainly do locally, and run one of the DeepSeek models and ask it a question, you will see it reason. You will see it ask itself a lot of questions and go through the
Yes.
process of generating a chain of thought reasoning approach. And it'll say, well, that's wrong. I need to try something different. And it's actually fascinating to watch.
Yeah, it's interesting because there are other large reasoning models out there. In fact, some of the OpenAI models, O3 for sure, and I think O1 do, or at least some of the flavors of O1 are reasoning models. But what's cool about
Mm,
DeepSeek R1 is it exposes more of its reasoning to you, the user. So it gives you a very verbose,
right.
almost
Yep.
too verbose peek into how it's thinking, because it will say, "Hey, here's what I think I should do," and it actually does say that in very informal, chatty sort of dialogue. It says, "Well,
Yeah.
I think I should approach it this way." It's almost like a mad scientist talking to him or herself.
It's
Um,
amusing. I
yeah,
encourage somebody to go out there and do it. I loaded it up on my laptop, my MacBook. You can do it with something called a llama. It makes it very easy, and you can sit there and you can query these models and see it generating how they. I hate to use the word think, but how they think and how they create this
yeah.
chain of thought. It's just fascinating how they
Yeah,
operate.
and if you don't want to install Olama, you can also use a number of public services. I know,
Right.
for example, that Perplexity, I'm not sure if Anthropic does, but there are a couple of places that you can use US hosted versions of DeepSeek. So
Yes.
you're not sending information outside US borders if you're in the US. And as you said, Peter, it's fascinating to watch it think, and I'll say that in
Yeah.
air quotes. Um, yeah.
But
So,
this is, and again, this is what these tools are phenomenally now getting really good at solving complex business problems. And this is
right.
where, again, this is not just you get a reasoning model and my problems go away. They're still incorporating. RAG and fine tuning to make those models even more applicable to your specific domain.
Yeah, yeah, cool stuff, right?
So
It's
yeah.
absolutely fascinating. All right, but you mentioned another cool thing, which is deep research. Um,
Oh, yeah. Now, let's talk about this a little bit because I think this is a for a lot of problems, and again, not all problems, but for a class of problems, it's an awesome tool to use. So I read X fairly um, constantly because there's a lot of information about artificial intelligence on there. It's a great place of source of information, and I read some of the, those that are thinkers, lead thinkers in the space. Anyway, so it hit my feed that this week about deep research from OpenAI, which was fairly recently released, and
yeah,
it is a reasoning model. And I had a class of problems that I normally would have sat down and I would have spent weeks researching and scouring the web, looking for information, bringing it together, and creating a report. And it would have taken me hundreds of man hours to do what it literally did in less than 30 minutes. And can it make mistakes? Does it make mistakes? These models all make errors. But the results, it saved in terms of time, probably tens of thousands of dollars.
right. And it's interesting because I think on the personal usage front for models, so separate from building systems with generative AI models embedded in them, on the personal front, one of the ones that is most exciting to me is how to use these models as learning tools for
Yes.
growing our own knowledge. And unlike you, I have not yet played with deep research because at least as of the time that we're recording this in early February 2025, uh, deep research is not publicly available, but people who are special like you, Peter, can get access to it. Um, but I think that's probably the thing I'm the most excited about is using it to help
Oh,
continue to learn new things.
I could only imagine if I had this when I was young in high school and college, having a tool that I can interactively ask questions and get a response back is to me just incredible. Not going to a library and scouring through stacks of books to find a response. It just, yeah, they are incredible learning tools, and I think you'd be foolish not to leverage them. Anybody would be foolish not to leverage them as learning tools because ask a question, get an answer, and then ask why and get a response back. And yeah, you got to sometimes put it through a lens of is that 100% correct? But it still, as a learning tool, it's incredible what you
Yeah.
can do with them.
Absolutely. The one that I do use frequently is Notebook LM by Google,
Yes,
and that has
yes.
Gemini sitting under the covers, and it's a phenomenal tool for learning and research. Now
Mhm.
that works, I think, a little differently than deep research because
Yeah.
you have to give it the initial set of documents and websites and other sources of information that you want it to use. But you can upload and provide, I think it's about 50 is the limit. PDF documents, Office documents, you can point it to
Right.
websites, you can point it to YouTube videos, and you're basically saying, okay, this is the universe of documents I want to work from. And then what's really cool, excuse me, in the early versions, you would ask questions. Now, what's cool is it will start by generating an overview. It'll generate a briefing
Right.
document. It'll generate a essential questions document. And my favorite is it can even generate a podcast. So I think
Oh, I love that.
yeah, and for anyone who hasn't tried it, it's really cool because it will literally take the information that you supplied. You can say generate an audio summary, and it will put it in the form of a two-person podcast with two completely fake but convincing humans
Very realistic humans.
going back and forth and discussing this topic. And that is a really interesting way to get maybe your toes wet on a complex topic. It's not going to give you
I know.
everything you need to know, but as a way to sort of get an introduction, listening to two people chat about it for a half an hour is pretty useful.
Oh, it's amazing. After you turned me on to it, I took a book on artificial, like an academic book on artificial intelligence and machine learning, a 400-page PDF, and I uploaded it, and they said create a podcast for me, and it did. I didn't listen to all of it, but I listened to a big part of it, and I was utterly amazed. I mean, it sounded like two individuals sitting there chatting away. It was not robotic. It sounded very real. It was frighteningly good.
Yeah, and probably the coolest new feature is you can interact with the audio track now. So you could
Oh, I didn't know
become
that.
a third participant in that virtual podcast. Now, it's not as smooth as the generated
Right.
podcast because it goes away and it spends several minutes generating the podcast, and then you get an audio file that's seamless. This has a little bit of latency as you go back and forth, but the
Right.
ability to sort of participate in the podcast and ask follow-up questions and ask for more information or ask for clarifications is game changing.
No, 100%. No, it's amazing, actually. I will say this, and you and I have not spoken about this, I think, enough, is the Google models are phenomenal. I would
Yes.
argue that they're actually, if not the best, some of the best models out there.
Yeah.
It's very impressive what they've done.
I have so many mixed feelings about models. I think first of all, I do think that some of the Google models, some of the Gemini models are some of the best I've ever seen, and they're phenomenal. And I think they're, very competitive even with DeepSeek R1 and the OpenAI models. At the same time, what gets me personally the most excited, what I find the most useful and game changing, isn't necessarily the advances in the models, it's the advances in the way that we interact with the models, right? So
Yeah,
being able to interact via a custom podcast that's generated from documents you supply, or
right.
being able to have back and forth Q&A and discussions, which you can
Yes,
do in OpenAI, you can do in Google, you can do in a number of tools, or some of the tools that Anthropic provides for being able to,
right.
create a canvas and interact. That's where it gets really interesting to me.
Yeah. Yeah, no, integrating them with other platforms is just because they become useful tools, very
Yeah,
useful tools. And you
yeah,
become incorporated into your daily. And you and I have used these things, many of these tools extensively. And
right.
again, I look at some of the work that you and I have done with these tools and how it's just we brought it into our business and how we create content and we use them for analysis and generation of proposals or whatever it may be. They have saved us collectively thousands of hours of work.
I have a confession. I'm not actually here right now. I'm in bed sleeping. This is a completely
This is
AI
this is
generated
this is
version
this
of
is
David. Yeah,
AI.
I'm sorry to catfish you like that, Peter, but you've been talking to my AI avatar for the last 50
That's a
minutes and
pretty
I
damn
went
good
back to
avatar.
bed. Yeah.
Have to say I'm
So
fairly jealous of you. I wish I was in bed too.
so clearly that isn't quite true, but there are even, we've tested out some technologies that allow you to create a live video avatar of yourself that can answer questions based on
Oh,
content you provide. So if I were to upload everything I'd ever written, maybe upload all my diaries and everything I've ever written, maybe this avatar could do a reasonably good impersonation of me. It's still pretty crude, but it's scary to think about, someday I'll be able to create a digital twin.
oh, 100%. It's funny, and that maybe it's a little dark, but it's all my dog passed away over the summertime, and I had this picture of him, and I'm like, let me bring him back to life again because I was testing some of the technology, and I figured it was a good test of technology. So I took a static picture of him and put it into it, and I said I want to see him happy and jumping around, and what came out was frighteningly good. You couldn't
That's
tell the difference between what was him alive versus it was frighteningly good.
it's simultaneously intriguing and disturbing.
100%.
Yeah,
And that's the
yeah.
thing about it. I'm looking at this going, why did it even do this? But in the same note as I was intrigued to see what it would generate. And what it generated was it was the way it wagged its tail, the way it jumped, it was like, wow.
Well, you and I also both have kids in academics. Mine's in high
Mhm.
school. Yours are a little older than that, but it's also interesting. And you and I know we chat a lot about this, but these tools are changing the way kids learn.
Mhm.
And I spend a lot of time wondering how much schools should be embracing this and how much they should be pushing back because there's no clear answer to that.
Well,
But
and it's funny because I look at it and go, you need to embrace them. They're not going away. In fact, it's coming at you at a rate of change and a rate of speed that you need to embrace it. You need to incorporate it into your curriculum. You need to learn, teach them how to use these tools effectively, because if you don't, they're going to figure out and do it themselves, and it might not be the right way. And then rather,
Yeah.
enable them to use, and let's face it, they're powerful. They're very powerful. This is the type of technology that comes along once every 100 years that truly revolutionizes things. And you need to know how to use it and use it effectively and efficiently and for the right reasons.
Yeah, I mean, honestly, I would say that most institutions, whether at the collegiate level or secondary education, that have mandatory training courses probably would be better served by switching to a mandatory generative AI course,
Hmm.
because I think that, this has been said by many people far more eloquently than I can say it, but our competitions as humans, it's not going to be a case of humans being replaced by AI for most people. It will be a case of humans competing against humans who use AI more effectively than you do.
100%. 100%. And just to give you an example, what I did this week, when I was playing with the reasoning models, I took an old college math book from, when I took advanced college math analysis classes and number theory and all this esoteric stuff where, a single line on a page requires a 40-page proof. And I typed in one of the theorems that was in the book, and something I no doubt had spent many hours proving when I was in college. And I said, prove it, and then explain it to me and come back. And it explained it in a way that I never would have, a professor probably wouldn't have been able to easily do, but I was able to go back and ask questions. And so you
Yeah.
walk away with a far deeper understanding and appreciation of, whatever it is I'm asking. And it was like, wow, I wish I would have had this in college. It would have taken this incredibly painful class and made it, not I wouldn't say survivable. I probably would have learned a lot more
Right.
because I can operate at my own speed. I can ask the questions because I'm missing something, and it's coming back with a response. I'm like, I wish I had this in college. It's incredibly powerful
Yeah.
when it comes to learning.
I get just very, very intrigued and almost emotional about the idea of being able to like equalize the learning field, because you can give people access to information in the form that they can best
Right,
consume it, right? You
right.
can, if I want to see a video, if I want to hear a podcast, if I want to talk to a virtual professor and work things out verbally, or I can read, or I can consume it in whatever way is the best. And that just feels ground changing, groundbreaking, game changing, whatever I'm trying to say,
What do you want to
because
call it? It is.
yeah,
And you and I have spoken about this
that's
multiple
cool.
times. Like, how do we even take these models and make them domain specific for specific problems? Because, like you, and we've even talked to clients who wanted to have interactive tutors. And
Yeah.
I think I get incredibly excited by that because I realize, having that highly custom, basically a custom tutor for myself that operates the way I operate, and I can ask it the way I want to ask it questions. And to me, that's just incredibly, incredibly empowering. And to think of it anything other than that is foolish. You're just defeating yourself.
So, look, we're not naive. We spend a lot of time in our professional lives and when we're just talking with each other, talking about AI safety and ethics and
Mhm.
responsible AI, and that's a big part of building systems. Like we know that.
Right,
But
right.
despite how much effort one has to put into AI safety, and despite the fact that I think we are realists, I think we're very bullish on this. Like, let's be clear. We're not
Oh, absolutely.
Pollyanna and we're not naive, but we're very bullish on what this technology can and hopefully will do for all of us.
No, I think you and I are very, I couldn't have said it more eloquently than you. We are extremely bullish on this technology. I think we believe it is a true game changer. I think we're also tempered by experience. We recognize it's going to take a long time before the full potential is realized. And that's not a year out from now. That is a decade out from now.
Right.
It's just, it takes a long time for people to catch up with something as powerful as this. And, having gone through the internet explosion, the advent of the internet, and the advent of the smartphone and all these different technologies that have come along in the last 35 years, we know it takes a long time. The hype phase is ending, the hard phase is beginning, to really get a lot out of it, but the possibilities are virtually unlimited and incredibly powerful, and will have a deep broad impact on civilization. And that's not me with a bunch of hyperbole. I think that's exactly what it's going to be like.
I feel like I should break into the song about a bright, shiny new tomorrow from the Carousel of Progress at Disney World. But well said. And the good news for everybody is I would never attempt to sing. Um, but listen,
Neither would I.
it's been a fascinating conversation, Peter. I always enjoy when we get to
Always.
just make some time to talk about this stuff with each other,
Yep.
and hopefully it's useful for other folks to participate and listen in. Um,
Yeah, I hope everybody enjoyed it today. Again, this is the first of many of these. We try to keep them interesting. We know we ramble occasionally, but we at least try to incorporate some real good nuggets of, things that we've learned in our journey through, working professionally for 30 plus years and working in this technology for a long time.
and now that we're doing
Right?
these live, tune in next Thursday to see what kind of shirt I will wear next week, and whether Peter ups his shirt game and
I have
tries
to
to
measure.
outdo me.
That's a if that's a competition, I'm gonna have to win it. All right. I'll pull something out of the wardrobe.
Excellent. All right. I
All
think
right.
that's it for today. Thank you for joining, and
Yes.
we will see everyone next week.
Thanks,
Take
everybody.
care.
Have a great day.
Goodbye,
Thank you for
everyone.
listening. Bye now.